Welcome to VLearn. I am Sarulak and today I am going to discuss Bresenham line algorithm. So previously we have discussed the line generations according to digital differential analyzer, and you know the equation of line is y equal to mx plus b. As we discussed earlier, where m is the slope and b is the constant according to y. Means we say that b is the y-intercept, and we discussed already earlier that m is the slope, and we can find the value of m from y2 minus y1 by x2 minus x1, and we say it delta y by delta x. Means delta x, as we discussed earlier, delta y is y2 minus y1, and delta x means difference of x, and this is from x2 minus x1. And now we are going to discuss Bresenham line algorithm. You see, look, this is the plotting pixels. Here we have to plot the line from start to end, point P1 to point P2. And we represent, this is called yk, and this is the point from where line penetrate to P2. So here is the integer pixels. This is the pixels and this is the pixels. As we discussed earlier, Bresenham line generations algorithm works according to integer point. So if the line penetrates from here, then we have to find the distance of integer value. Means from here, this point is closer or this point is closer. We have to find decision parameter. We have to find decision parameter. We represent it with T. So we have to find the decision parameters. The line goes from D2 or goes from D1. So we have to calculate the distance from here to here and from here to here. So how can we calculate the distance? So first of all, we represent this point P1, this is called y, and this point, the next plotting point is yk plus 1. This is the next plotting point, and this is the xk, and this is the next plotting point xk plus 1. So, and where we plot the pixels or where we put the pixels, we represent this with x or y. So, as you know, the equation of line is y equal to mx plus b. So, what is the value of y at k plus 1? We have to find the value of y at k plus 1. Y at k plus 1, we know the equation of line is y equal to mx plus b, and we have the value of x. This is the xk plus 1. So we have to find y at k plus 1. We represent this m, and we know the value of x, xk plus 1. So the value of x is xk plus 1, and b is the slope. So b is the slope. So, and we have to find the distance d1. This distance is called d1, and this distance is called d2. So if we find the value of d1, then how we find that? This point is called y. We represent this point as y. So if we find the value of d1, then we have to subtract the value of y from yk. So when we subtract the value y from y to yk, we find the d1. We find the distance of d1. So now the distance equation is d1 equal to y minus yk, and we have the value of y at xk plus 1, mxk plus 1 plus b. So d1 equal to m, the value of the equation of line is mx plus b. The value of y is this mxk plus 1 plus b. So we find as mxk plus 1 or plus b. This is the value of y or minus yk. We have to find the value of yk. So d1, the equation of d1 is d1 equal to mxk plus 1 plus b or minus yk. This is our equation first. Now we find the value of d1, and again similarly we find the value of d2. As you know, the d2, we represent d2, if we find the value of d2, then we have to subtract yk plus 1 minus y. This point is called yk plus 1 and this point is called y. So if we subtract the value of yk plus 1 minus y, then we find the value of d2. So when we find the value of d2, then we have to subtract the value of y is yk plus 1 and minus y. Yk plus 1 minus y. Now we know the yk plus 1 or minus the value of y is mxk plus 1 plus b. So when we find the value of d2, then yk plus 1 minus y, and then yk plus 1 minus the value of y is this yk plus 1 minus y, the value of y is this. So we find the value of d2, yxk plus 1 minus mxk minus m. We multiply the value of m into 1, so we get the value minus m, and minus b. So we get the equation of d1 and we get the equation of d2. According to these equations, we find the value of d2, we find the distance of d2 from yk plus 1 minus y, and according to these equations d2, we find the distance of d2. So now according to these equations, we find the value distance of yk plus 1 minus y, and we find the distance of d1, that means y minus yk. Now we subtract d2 minus d1. So we find the value of d2. When we subtract d1 minus d2, then we put the value of d1. We find the value of d1 is this mxk plus m plus b and minus yk. This is the value of d1 and this is the value of d2. Yk plus 1 minus mxk minus m. So we plot d1 d2 2mxk plus mxk. We find that 2mxk minus 2yk. This is the yk and this is the yk. So we get the value of 2yk plus 2m plus 2m plus 2b. We have the value of 2 plus 2b or minus 1. So we get the value of d1 minus d2. We don't want floating point, ignore m. We don't want floating point, ignore m by multiply delta x on both sides. What will be the value? delta x d1 minus d2 equal to 2 delta yk minus xyk xk minus yk plus 2 delta y plus 2b delta x minus delta x. Let delta x d1 minus d2 is equal to pk and A equal to C. This is called decision parameter. So let me represent d1 minus d2. We multiply both sides to remove floating point. So if we want to remove floating point from both sides, we have to multiply both sides with delta x. So d1 minus d2, we multiply with delta x, and this equation is multiplied by delta x. So the value of m is, this is delta y delta x, and when we multiply it with delta x, we can snap the value of delta x, and now the value of 2 delta y xk. So we have to find out 2 delta y xk minus 2 delta x yk. We multiply it with delta x plus 2m, this means 2 delta y. M means, this means delta y by delta x, and when we multiply delta x across, so we get 2 delta y and plus 2b, that means 2b delta x, and minus 1. When we multiply delta x with 1, we can get delta x. Now we sort the equations. Let we represent these equations with pk and these equations with c. So the equation is, the decision parameter is pk is equal to, we represent of whole the equation is represented by pk. So when we plot the pk, that means we get this. So we represent pk equal to 2 delta y delta xk, 2 delta y xk minus 2 delta x yk and plus c, because we represent this whole equations with c. So we find the value of decision parameter is, we represent, here we find the value of decision parameter and we represent it with pk. So we can say that pk equal to this. So when we find the value of decision parameter, then we apply these equations. So this point to be noted, like we remember these equations, like we noted with here pk equal to 2 delta y xk minus 2 delta x yk plus c. We represent these equations 2a. And we find the next point. That means next decision parameter pk plus 1 equal to 2 delta y xk plus 1 minus 2 delta x yk plus 1 or plus c. This is the plotting point, and we find the next plotting point. Now we find pk plus 1 minus pk. So you have two equations pk, the value of pk is this and the value of pk plus 1 is this. So when we find pk plus 1 minus pk, so pk plus 1 is equal to pk plus 2 delta y minus 2 delta x into yk plus 1 plus yk. This is the next plotting point, and we represent it with equation 3. Now if we get the value of p less than 0, when we find the value of p, we get the value of p either greater than 0 or less than 0. So if we get the value of p less than equal to 0, then yk plus 1 is equal to yk then from equation 3 we get this equation 3, we put the yk at yk plus 1. So we here find yk plus 1. So when we replace this yk plus 1 with yk, and we get the equations pk plus 1 is equal to pk plus 2 delta y, pk plus 2 delta y. else yk plus 1 बराबर है yk plus 1 and from equation 3 we get pk plus 1 is equal to pk plus 2 delta y minus 2 delta x. This is our final equations. When we get the decision parameter value is below 0, then we replace at yk. We replace yk at yk plus 1. So we have the value of yk plus 1, we replace the value of y, and we get the value pk plus 1 equal to pk plus 2 delta y, because when we replace this will be 0. Else, if we find the value of p greater than 0, then we replace yk plus 1 with yk plus 1. So we have the value yk plus 1 is here, and we replace this with yk plus 1, and when we plot the value of yk plus 1, we get the value pk plus 1 equal to pk plus 2 delta y and minus 2 delta x, because yk and yk may be cancelled. We plot next point according to this algo. And now we find the value of first point. That means we find the value of first point means P0. Put xk equal to 0 and yk equal to 0 in equation 2a. You see, the equations 2a I already discussed, which you have seen earlier, that which equation is called 2a, you have the value. So when we plot in equations 2a, you equate where you find xk, when you plot replace it with 0, and when where you find in equation 2 yk, we replace it with 0. So we get P0 is equal to 2 delta y x0 minus 2 delta x y0 plus c. And when we plot this is 0 minus 0, or this is 0 minus 0 plus 2 delta y plus 2 delta y minus delta x. So we find P0 equal to 2 delta y minus delta x. 2 delta y minus delta x. According to these equations, we find first point. First point डेल्टा x बराबर है x2 माइनस x1, डेल्टा y इक्वल टू y2 माइनस y1 और p इक्वल टू 2 डेल्टा x 2 डेल्टा y माइनस डेल्टा x और पिक्सल x y y for I equal to 1, I less than equal to delta x I plus plus. If p less than equal to 0, तो p equal to p plus 2 delta y, else y बराबर है y plus 1 और p equal to p plus 2 delta y minus delta x pixel x y 1 and x equal to x plus 1 x equal to x plus 1. This is the algo of resonant line generation. First of all, when we when we plot the pixels in Bresenham algo, when we start the right to algo, we find the distance of x, means difference of x. How can we find the difference of x? Means dx or delta x, we subtract x2 minus x1, and when we find the value of delta y, we subtract y2 minus y1. And we have discussed that how to get the decision parameter, that means the value of p. We discussed earlier the value of p equal to 2 delta y, that means we say that 2 dy minus dx. The value of dy we know and the value of dx we know. According to these equations, we get the value of p and we plot the pixels x, y, and this is the color code. So the pixels to be plotted at the destinations, and now we increase the loop at difference of x, means dx. We start the loop from x1 to difference of x, and we test. We discussed earlier that if the value of p is less than 0, then we find the equations. If the value of p is less than 0, then we have to plot the pixels according to these equations, and if the value of p is greater than 0, then we plot the pixels according to these equations. When the value of p is less than 0, we plot the pixels according to this, and y coordinate is not going to be incremented. While when the value of p is greater than 0, we increment the value of y coordinate, and we find the plotting pixels according to these equations, that means p equal to p plus 2 delta y, means dy, minus 2 dx, means delta x. And this is repeated unless we got the value of dx. So when the value of p is less than 0, then we plot according to these equations. X is going to be incremented, that means x coordinate going to be incremented, but y don't going to be incremented. And when the value of p is greater than 0, then we plot the pixels according to these equations, y coordinate going to be incremented and x also going to be incremented. The value of p is greater than 0, less than 0, x going to be incremented, but y is not. Y coordinate going to be incremented either in case when p greater than 0. So when let's take an example. Draw a line joining points. B is this and is at 30 using this and algo. How can we plot the pixels? Value of k, decision parameter pk, x coordinate, that means xk plus 1 comma yk plus 1. Next point to be plotted. This is k. The value of k is less than equal to dx. So we get the value of, so here x1 is equal to 20 and y1 equal to 10, x2 equal to 30 or y2 equal to 80. We find the difference of x, that means difference of x, delta x, as we know, we get the value of dx when we subtract x2 minus x1. That means 30 minus 20 is equal to 10. The value of Start. Now we start. We have to draw a line from this point to this point. We have P1. The value of P1 is 2010 and we have P2 where we plot the point. The value of P2 is 1380. The value of P2 is 3018. Now we have to plot a pixels from this point to this point. How can we plot pixels according to Bresenham algo? So first, according to Bresenham algo, we find the difference of x, and we know that in these equations, in this point P1, the value of x1 is 20 and x2 is 30. And when we find the value of dy, we get it from the value of y2 is 18 and the value of y1 is 10 according to this. So when we find the difference of x, we get x2 minus x1. We get the value of dx is 10, and when we find the value of delta y, we get it from y2 minus y1, and we have the value y2 18 and y1 10. So when we find the value of delta y, we get 18 minus 10, we get 8. So we find difference of x is 10 and difference of y is 8. the value of k, as we know here the P1, this is the origin point. According to equations we find the value of P0 and the value of Pk plus 1. According to these equations, the value when we plot the first pixels we plot according to these equations, and when we plot next point we plot according to Pk plus 1, and the equations of Pk plus 1 is this, means P next. So we have to plot the first point. So the equation is P0, we say it P or P0 equal to 2 delta y minus delta x. So we get the value of dy, which is 8, and we get the value of dx, which is 10. So when we calculate it, 2 delta y minus delta x, we get 2 into, we have the value delta y is 8 minus delta x 10. So we get the value of P0 is 6. The value of k is according to the value of dx. The value of dx is 10, so we plot the k 0 to 9. This is the difference of x. And at origin point we plot, we find P0 is 6, so we plot Pk is 6, and the plotting point is xk plus 1 and yk plus 1. As you know that when the value of P is greater than 0, then we plot xk plus x is going to be incremented and y is going to be incremented at P0. So we have the value of x is 20, so xk plus 1 is 21 and yk is 10, yk is 10, so next point to be 11. Now we get the value of pk is 6, and this equation is repeatedly, this loop is repeatedly working while the value of I is less than or equal to dx, that means 10, means 1 to 10. And if p, which is 6, less than 0, the condition is false, then the process is going to be else conditions, and the y is going to be incremented by 1. So the value of y is, we have the value of y 11, the value of y is 12, and we find the value of p according to these equations. So when we plot the value, p is equal to p plus 2 delta y minus 2 delta x is equal to, we have the value of p is 6 plus 2 delta y, 2 into, we get the value of delta y is 8 minus 2 into, we get the value of delta x is 10. So delta x is 10. We get the value of p is 2, so we plot the value 2 at pk and plot the pixels at x 22, because x is going to be incremented 1 and y is incremented by 1, 12. Now again, the value of p is less than 0, the condition is false, then according to this if statement, the condition goes in else conditions, and we find according to these equations the value is minus 2. That means we plot the value at the p is 2 plus 2 into delta y is 8 minus 2 into 10. So 2 plus minus 2. So we plot the pk is minus 2 and the value is going to be incremented. Xk plus 1 is 13 according to these equations, and y not going to be incremented. Sorry, y going to be incremented 12 to 13. Now the value of p is greater than p. Value of p, we get the value of p is minus 2, which is less than 0. So we plot pixels according to these equations, and when we plot according to these equations, we get p equal to p plus 2 delta y, means p, we have the value p minus 2 plus 2 into delta y is 10, delta y is 8, minus 2 plus 16 equal to minus 14. We plot the value 14, and y not going to be incremented, but x is going to be incremented. So x is 24 and y not going to be incremented, so it is 30. And this equations is onward up to 9. You plot according to these equations. If the value p less than 0, then you calculate pixels according to these equations, and we get the value pk greater than 0, then you plot according to these equations. This is Besenham line generations algorithm. As we discussed, the value of k is start from 1 to dx. The value of k is start from 1 to delta x. You know how to calculate the value of delta x? This can be calculated from x2 minus x1. Okay, any doubt? Okay, now we have finished the Besenham line generations algorithm. If you have any difficulty in equations or in plotting pixels or in examples, you may ask. So you have to practice of Besenham line generation algorithm according to points, according to various points. You take various points, and according to that point you have to calculate the value of xk plus 1 or yk plus 1, the value of k and the value of pk. How can we calculate the value of k? As we discussed, the value of k start from 1 to difference of x. We represent it with k. So you can easily understand k equal to 1, k less than equal to dx, and k plus plus. And we calculate the value of pk according to these equations. If the value of pk less than 0, we calculate next pk from these equations, and if the value of pk greater than 0, then you find the value of p according to this equation. When the value of pk is less than 0, then x is going to be incremented and y is not going to be incremented. And while you find the value of p is greater than 0, then the value of y is going to be incremented and the value of x is also going to be incremented. now we have finished the Bassenel line generation algorithm, and now we move the circle generation algorithm.